All right, so let's do some coding. So, a couple of things here is that I don't quite like using interface here. I know it's pretty super common in Angular and generally in JavaScript and TypeScript to use interfaces. I don't like that. It's because like interface has no like an identity in itself. What we should be doing is using classes. It's also violating some of the rules in Solid, like interface segregation. But we're gonna talk about it a little bit more in the future. For now, let's just focus that whatever model we get should be actually a class. So what can we do? Let's do the TDD approach. I'm really big on TDD. You can read about all its benefits. I think you can be called senior if you don't use TDD, or if you don't even test, that's super junior. So what you should be doing is to focus on the tests. So here we're going to be doing the unit test. We're using Jasmine. It gets bundled with it, with the Angular. So let's just use it. We're going to make a separate video about it, what to use Jasmine over JS or some other framework. But okay, so the very first thing in TDD is to write a failing test. So we always start with should create. This is like the most basic stuff we can do. So let's say it should create. And then of course we want to be creating the model. So new user model. And then we can say expect model to equal, and now I can check for the type, Jasmine and user model. Cool. Well, the thing is that the user model is not a class, so obviously that's not going to work. Even if I want to include it, it's not going to work because of this new. So this is actually a failing test. I know it's like stupid to run it, really, like everyone can see it's not working this way. It's not going to work, but remember, the first step in TDD is to get the failing test. And wrong imports or wrong models will end up in a failing test. So obviously it shows cool is because it's a special case in which cannot find the user model, the imports are not there. Of course, if I import it, it's going to import an interface, not the class. So let's try to make this code pass. So that's the second step in TDD. Green, which means allows us to pass. So let's forget about those things. Make it a class, then import it in here, and let's see what's gonna happen. It's gonna take a while. You might fast forward. Okay. We have some karma error. It disconnected on the first one. Let me try it one more time from the beginning. So the first launch of it is like we have to set up all the karma server, and I'm using the Chrome headless browser, so I don't get the pop-up all the time. It takes a bit of time to actually set it up because there's a whole browser running behind it. But it's getting faster with the continuous testing approach. Okay, good. You see, it's a full green mode. Here we say total 1 success. Great, we are in the green stage. Now we're gonna move to the next one called Refactor. So, do we have anything to refactor? Like, it's so basic, I would say no. But it will make use of it that the stage of Refactor will be very useful for the future. So let's look, okay, what can we do here? Well, obviously this expectation is very basic. It's not doing anything really. So let's actually focus more on writing the spec for my code first in the test. So we get back to the new cycle of TDD. So just to recap, a TDD follows red-green refactor stage, in which red means failing test, green means minimum code that satisfies the test. And then the refactor is where we actually optimize the code to still pass the tests. You might also actually optimize your test code, but we're gonna talk about it more in the future. So what can we do? Well, let's actually define what the user model is. So what we can do is we can say to equal, instead of Jasmine user model, we can say, I believe it's Jasmine object containing. And here we can say what kind of thing it should contain. And as we said, we say login, and it should contain some sort of a login. Remember, we are in unit test. It doesn't matter what the business goals are. It matters, you know, we verify that the software works. And then we have avatar URL, and that's gonna be some sort of HTTP github.com/avatar.jpg, like simple stuff like this. Okay, cool. Well, that's not gonna work, obviously. So when we run that test, it should fail. Okay. For now, okay, sure enough, it fails. For now, what we can do is I can split it horizontally. This is sort of like how I like to code. On the right, I have my tests. On the left, I have my models or production code. Okay, so we know it doesn't work. So what is the minimum I can do to actually make it pass? Well, the minimum would be to make something like this. So I make a local variable that is a login, and I make the avatar URL, which represents exactly the same thing here. So I know it's silly, but bear with me, it will make a lot of sense. Yeah, and here you see the problem I mentioned in the previous video about the camel casing. For now, I'm just gonna ignore it for now. My goal is to make the test pass. Okay, hopefully that's gonna pass if the TS length is not gonna go against me. So this test obviously is silly. I mean, I cannot use the user model for anything else than just something called login and this GitHub URL. But it passes, so it's good. So what we can do is, like, you have to shift your mind a little bit when you do TDD. A lot of people would be actually writing the full implementation here, but that's not the goal. So the goal is to do very small incremental steps. The next thing is refactor. As I say right now, still I wouldn't say there is any rule that we violate per se from like static code analysis perspective, except of the URL here. But keep in mind that I also want to keep it in sync with my components. So what we can do now is to actually go back to the red state. Okay. Obviously, I don't like that we are providing data like this. So also there is an immutability problem, like we are allowed to mutate those variables. So what we can do? Well, we can actually create a variable out of it. Login, which will be a login in our test. And then we're gonna have avatar URL. Here I'm gonna keep it beautiful camel case. All right. Now I'm gonna provide this in here and in here in the constructor. This actually helps me to encapsulate my models. And of course here is just, I can just use this. And then in here I can use this. Cool. Well, that's not gonna pass. You can believe, I mean, I can already see it in here that you expected arguments and they don't exist. So what can we do? We can actually rewrite the code, right? So one way to go about it would be Yeah, and of course the count breaks. So just a second. So what we can do is to write a constructor, because now we need a constructor. And in a constructor, the easiest way is to have a public variable called login, which is a string, and avatar URL, which is a string as well. Now I can remove this code, and that should do. Maybe make it public. So that should pass. However, so if it passes, we can already think about some optimizations. So the refactor state comes into play. So one thing I really don't like in this piece of code is that this is public. So why is it a problem? Well, you see, JavaScript is this funny language in which mutations are pretty serious. I mean, if some lower layers or lower components get access to this object and start to mutate it, like I can call set login very easily on it. And that's the problem, because I don't want to allow people to do it. So an alternative way would be to use getters. So what you could do, let's just wait a second to just make sure it's passing. Here we go, it's running now. Cool, it's passing. So what we could do instead, we could do like this. So make it private, and then call a login as a getter, and that way we are preventing, I mean, we know it's TypeScript, that gets translated to JavaScript, so this is just a concept, it's not really how it works, like you can always mutate it. But I mean, I'm talking about the code perspective, you know? So you could just return this login. Well, that's good. It's pretty good, actually. Obviously now we have a problem with creating two variables of the same type. One way is to actually prefix it with the underscore and stuff like this. So it's okay, but I think there's a better way. So what is really happening here? Why is it a problem? Well, one problem is that, let's say you want to persist that into some sort of maybe local storage or some sort of persistent layer, or maybe in a state. The problem is that it will actually persist those private variables, and it will not persist the getters, because this is a class property. It's not a data structure per se. I mean, it's not like this login is part of like a property. It's an accessor to the property. So you will not persist this thing unless you bind it again. So it will create a lot of boilerplate. So what I found out that is a neat approach to it is to use public here, but put read-only. I mean, guys, you probably have some opinions about that. If there is a reason why I shouldn't do it, please do share it in the comment section. I'll be more than happy to review it. But for now, I found it like the easiest and nicest way actually to work with it. Okay, so we have our private read-only. That's good. And then let's get to this. It really starts to bug me. I don't think we should do the URL like that. Here we go. We got URL like here. Now I don't need this because it's actually the same name of the variable. Okay, cool. Let's see if this refactor helped. It definitely helped from the perspective of changing a lot of stuff that preventing me from setting those guys. So it's pretty cool. If that works, that should be pretty much it for now. Yep, it works. Okay, good. That was a couple of cycles of TDD. I think that's it for now. Stay tuned for more improvements.